Ladies and gentlemen, I'm pleased to present you a short summary of a system to quantify net carbon emissions and sequestration resulting from land use or land management practices. Before I introduce the system, let me introduce the authors. That is myself. Run my own consultancy. I'm a physicist. I've worked in human spaceflight, in astronaut training, vestibular physiology research, biology research in space, and have worked at the European Space Agency and worked together with NASA, Canadian, Russian, and German and other space agencies in planning and carrying out experiments in space. My most recent interesting area of work has been the utilization of space infrastructure to foster innovative, marketable applications. That means to encourage and make possible the use of space infrastructure used in an integrated manner, both with ground infrastructure and various types of satellites, in order to create new and useful commercializable applications. My co-author, Dr. Fabio Vescovi, he works with Cropin Agricultural Technology. He has a PhD in remote sensing in agriculture. And the company is headquartered in India, but has branches all over the world, including the Netherlands, where I am also based. So the subject of this talk is carbon emissions and the challenges faced in quantifying or measuring such things. We know that today many countries are creating laws in order to reduce carbon footprint of various companies, infrastructure, farming, etc. This is because it is considered that carbon emissions not only pollutes the air, but also causes increase in heating of the planet. However, how can these carbon emissions be reduced, and without measuring their reduction? One has to create a method of measuring the carbon footprint of an entity, such as farming, as we are concerned with in this application. And to measure that, we have to create a methodology, tools, and in order to do it in a fair and equitable manner. Now, we are not only measuring emissions, which are causing the pollution and causing the problem, but we should also be measuring sequestration, which is contributing towards solving the problem. In other words, the sequestration of carbon or the emission of carbon. Cutting down trees, for example, is reducing sequestrators. Burning crop residues, likewise. Planting trees or not burning the crop residues do the opposite. So in order to measure net values of a particular plot of land, one has to follow holistically a temporal approach using the various methods of measurement and adding them all up in time over a given period of time to see what the net difference of emissions and sequestration is, to come up with a figure of net contribution to one or the other. We'll go through a couple of scenarios. One is concerning crop residues. This is a problem because farmers have traditionally burnt their crop residues. That is the quickest method for preparation of the soil after harvest. But this produces large quantities of carbon dioxide. So we have to measure this and also in order to encourage farmers to use other methods, such as soil organic carbon, introducing that into the soil, we have to go through the sequence of taking satellite pictures over time, as is seen in the first scenario at the top. One sees where the residue in November in this picture is burnt. This will be measured and carbon debt is thus created. In the second scenario, instead of burning it, one is using introducing and integrating the crop residue into the soil. This is pretty good method of doing it. It contributes to the enrichment of the soil, and it is carbon neutral. Another scenario is the example of agroforestry. One can plant trees, but in order to know what one is doing, whether it has improved the situation, one has to follow that land before one started out the agroforestry in order to measure what that land was behaving like beforehand, during, and how it improves or does not improve with time. If trees are planted, then that does cause carbon credit, and if they're cut down, then it will be the opposite, as is here illustrated in the two sets of pictures. In the top set of pictures, you see how trees are planted, and you can see from left to right they get greener, and this is a carbon credit, whereas in the bottom, the trees are cut down for whatever reason, maybe wood or whatever, and this creates a carbon debt. And this is the same thing if you are going to create a farm on land that used to be a forest. You are not going to be helping with sequestering carbon dioxide. You might be actually creating a net emission, because before you did that, if it was a forest, then it would have been sequestering carbon, such as what often happens and has unfortunately happened is when forests have been burnt down on purpose in order to plant biofuel, corn, for example, and or whatever, and this has caused a net increase in emissions rather than contributing towards a green environment or contributing towards sequestration. So one has to be clean and looking holistically over time before one even dealt with that land, and looking at the history of the land even earlier over a longer period of time in order to assess the situation accurately. Now, how does one carry this out? It's not simply the set of pictures. The pictures have to be quantified, and methods have to be used. Kropin has worked on this quite hard and developed artificial intelligence models, looking at the data, measuring exactly what is happening, and then analyzing the models and the functions created and the analytical methods created to see whether they actually measure, predict, and quantify correctly either carbon emissions or reduction of carbon emissions. This time sequence of data is automatically stored in tables and creates what would be called a carbon model that can quantify the amount of carbon released or stored in tons. One must say it is not simply a matter of Earth observation and analyzing those tables, but also taking on-site measurements and calibrating, so to speak, those pictures, those images for that particular plot of land, so that it is not simply creating a model of measurement that works across all images anywhere and everywhere. One has to do also on-site measurement in order to do a proper calibration, and such calibration must be carried out every certain interval of time in order to make sure that they are still valid. These data are then fed into monitoring, reporting, verification platforms that are being used as a mechanism to measure and report carbon mitigation efforts, reward them, or charge them. If you want to find out more about how this is done and how you can eventually apply such a system yourself on your plot of land and have it a system of reporting in your own country, then please do contact us. Either contact me, James Kass, or contact Dr. Fabio Vescovi at Cropin, and we will be very pleased to provide you with further information. Thank you very much.